Hi guys, it's Mrs. Seitz, and today we're going to be officially building upon our lesson from yesterday when we were graphing those different video clips, and we're going to be officially analyzing some graphs that some are already sketched for us and other ones that we're going to be doing the sketching for us. All right, so today's lesson is analyzing and sketching graphs. You might want to have this handout from yesterday with you, so if you want to take that out before you begin today's lesson, that would be great. All right, so just to kind of remind ourselves from yesterday, graphs can show the relationships between quantities without using specific numbers on the axes. So most of the time, the word time is always going to be on the x-axis, and then we're going to see some other different quantities on the y-axis. But again, that can change, but for the most part, you're going to see time on the x-axis. Okay, we talked about this yesterday. If you see something linear, it's going to be happening at a steady rate. So this one is increasing at a steady rate. When you have a flat line, this is a constant rate. And then when you have something that is going downhill, this is decreasing at a steady rate. And these are all whenever you have a steady rate in the problem. If you have something that's a little bit more curved, these are the nonlinear situations. And we had some of those that happened yesterday. So if you remember like that hammer situation from yesterday with the intensity of pain, that would have been a nonlinear situation because it happened from slow to fast. The pain was increasing, but it didn't happen constantly. It happened increasing, so speeding up. If we look at this first two graphs, okay, we are going to be looking at and making some comparisons about the different changes in temperatures of two different cities throughout the day. And we're going to be describing the change in temperature in the cities based on the different shapes of the graphs that we see. So first we can make some comparisons about Belfast, Maine. So first thing I want you to do is to split the graph into the different sections that you see. So in Belfast, Maine, we're comparing temperature over time, and I actually see two different sections. I see the first section here and the second section here. And when I compare with my paper from yesterday, I think that first section kind of looks like the first underneath the nonlinear. So I think the temperature is increasing from fast to slow. So I'm going to write that down. And you can abbreviate like I do. Increased from fast to slow. From the second section of the graph, it's kind of curved again. So to me, it looks like this. It's decreasing from slow, and then it's speeding up. So it's overall decreasing. The temperature is decreasing slow, but then it's getting kind of cold, kind of fast, okay? All right, next thing we're going to look at Newport, Oregon. And we're going to split that graph up into a couple different sections. So I see 1, 2, 3 different sections. And these are all linear. So first section, it's decreasing, but at a steady rate because it is linear. So it would look more like this second graph under the linear function section. The second would be a constant rate. And the third section would be linear, and it would be increasing at a steady rate. So if we think about the temperatures in Newport, Oregon, it would be decreasing at a steady rate. It's constant, maybe through the middle part of the day, and then increasing at a steady rate towards the end of the day. So if we're making some comparisons about the graph, we can maybe say, maybe one observation would be both of the graphs are maybe showing maybe that we have increases and decreases overall, right? So we can say both show increases and decreases in temperature. We can say Belfast is warmer at the end of the day. And you can see that just kind of looking at the tail end of it than at the start. And you can say the opposite for Oregon. Newport is colder at the end of the day than at the start. You can also talk about maybe how Belfast's graph is more nonlinear. You could talk about how Newport's is more linear. There's lots of different comparisons that you make. I just came up with 3. All right, let's try another one. This time we're comparing these 2 cities. So again, we're talking about the comparisons of temperature. Okay, so let's split the graph into a bunch of different sections that we see. So again, I see maybe 2 different. So for Oakton, I see increase, and it looks more like this one, right? Increase from fast to slow. And then the second part of the graph, it's a decrease, but let's see which one it is. It more looks like this one, decrease from slow to fast. Okay, we look at Charleston. Let's split it up into 1, 2, 3, 4 different sections. Again, these are all more linear. So the first one would be increase at a steady rate. Again, the second one is also an increase, but it's at a more increasing of a rate. The third section is a constant rate. And then the fourth section is a decrease at a steady rate. Okay, let's make some comparisons. We can say that we have in Charleston has maybe a lower end temperature than maybe at the beginning of the day. We can say that, what else? We can say Charleston has steady increases and decreases because it's linear. And we can say Oakton has a higher end and start temperature than Charleston. All right. So guys, now that we did that, I want you guys to see if you can come up with the description for these 2 different kinds of birds. Now, we're comparing vertical distance. It says over horizontal distance. So just talk about the different sections of the graph. So again, split them up into the different sections. Just talk about the different rates that you see. Pause the video, see how you did. Okay, so on this one here, I would split the pelican up into maybe 2 different sections. And again, sometimes you can argue a couple different ways on these, okay? But with the pelican, I would say the first section is decreasing from slow to fast. And then maybe for the second section, it's again decreasing, but from fast to slow. So maybe that pelican's coming in down close to the water because it sees what it's going to take out of the water. It's making its approach and then swoops in right above the surface of the water. Okay, for the osprey, which is another kind of bird, it's coming in more at a steady approach. So it's decreasing at a steady rate. And then it's again happening at a steady rate. So decreasing at a steady rate. Okay, but who's actually going in the water? The osprey is. So when you take a look at the x-axis, the osprey actually hits the water. The pelican doesn't. So that could be a comparison. You could say the pelican glides towards the water. You can say the osprey has 2 steady rates. There's lots of different comparisons that you can make. I'm just giving you guys 3 possibilities. All right, for the second part, you guys are going to be doing some sketches similar to how we did yesterday, except this time you guys have to come up with the X and Y axis. So how we're going to do this is we are going to set up a blank XY axis for every single problem. It's always going to be a quadrant 1-1. Okay, so remember this is your x-axis, this is your y-axis. Most often, the x-axis is always going to be labeled with time. Okay, we'll have to see what the y-axis is in this one. Okay, so it says a stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while, then slows down at a constant rate until coming to a stop at the next station. Okay, so when we make this comparison, okay, distance over time is going to give us our speed. So I'm going to write distance here on the y-axis. Okay, and we're going to look through this problem to see if we're going to be using lines that are more straight or lines that are curved in terms of linear versus nonlinear in terms of our rate. A stopped subway train gains speed at a constant rate. Okay, well, first of all, this subway train is stopped. So when we first make our graph, we should be starting at the origin, and when we first make the first section, it's a flat line, right? Because as time's going on, nothing's happening. Okay, then it's gaining speed at a constant rate. So when we are talking about a constant rate, this would be something that is more linear, right? So it's increasing, right? It's talking about gaining speed. So that would be increasing at a steady rate for this next section. Okay, so here's part 1 of our graph. Here's part 2 of our graph. Okay, until it reaches its maximum speed. It travels at this speed for a while. I feel like that's our next part. So it's maintaining the speed for a while. So that's going to be pretty constant, right? And then it slows down at a constant rate. So again, I see that key phrase, slows down at a constant rate. So we're going to be talking about something that's linear. Until coming to a stop at the next station. So when we're stopped, time is still happening. So that would be the last part. Okay, so this is what our graph would look like for this sketch. Okay, let's take a look at the next one. Let's set up our XY axis. It says as the television size increases, the price increases at an increasing rate. Okay, so as our TV size increases, the price increases at an increasing rate. Okay, so it seems like we need to have price on here, and we have to have TV size on here. Okay, so as the TV size increases, the price increases at an increasing rate. Geez, that does not sound like it's linear. The price increases at an increasing rate. So when I look at these nonlinear sections, increasing at an increasing rate, it's got to be one of these two with the increasing. Increasing at an increasing rate. It'd be increasing but slowing down. That doesn't sound right. Increasing from slow to fast would be increasing as speeding up. So it sounds like it's going to be that one. So it seems like as the size increases, the price is going to increase. So that wouldn't be a flat line. We wouldn't be starting at the origin. So I'm thinking the price has to start somewhere, right? And we'd swoop up like that. Becomes steeper and steeper because as your TV size increases, so does that price. So this time it doesn't have time on the x-axis because we're comparing price with your TV. Okay, and again, it got steeper and steeper because as your TV size increases, that price is going to escalate and escalate and escalate. All right, let's see how you guys do on the last two. Okay, so we're going to be comparing in this situation, a fully charged battery loses its charge at a constant rate until it has no charge left. You plug it in and you fully recharge it. It loses its charge at a constant rate until it has no charge left. So let's look at that. Okay, so we're comparing the percentage of battery life over time. Okay, so a fully charged battery. So we're starting out, let's say at 100% battery. So up here, fully charged battery right there. It loses its charge at a constant rate. So that would be something that's linear and it's decreasing until it has no charge left. You plug it in. Okay, so we plug it in. Okay, then it's fully recharged. Now, when we fully recharge it, that's going to happen at a constant rate. Okay, it's not going to happen instantaneously. So that's going to happen at a steady rate. Then it loses charge again until it has no charge left. And then that process goes over and over it again. So again, that would be your answer for question number 2. All right, and let's see how you do on this one. Okay, as the available quantity of a product increases, the price decreases at a decreasing rate. So we have price and availability. Okay, the key phrase on this one is decreases at a decreasing rate. So I'm definitely thinking it's nonlinear. It's got to be one of these two because we're talking about decreasing and it says decreasing at a decreasing rate. So it's got to be this choice down here, decreasing from fast to slow because it says decreasing but slowing down. So here's what your graph will look like for question number 3. All right, so again, to do today's lesson, this is a nice little lifeline for you. Again, you're looking for those key phrases. If we're talking about something that's linear, we're using steady rate or constant rate in the description. If we're talking about something that's nonlinear, we're using phrases like decreasing at a decreasing rate or increasing at an increasing rate to talking about something that is nonlinear. The other thing we did in today's lesson is we also talked about describing different graphs, so breaking apart into sections and also making some kind of comparisons between those graphs.